You will need to perform these steps to complete this example. Let's get started. First, save the assembly to the 3DEXPERIENCE platform. You can use SOLIDWORKS Connected to store native SOLIDWORKS assembly and part files to a collaborative space on the 3DEXPERIENCE platform. A collaborative space is an area where people with different job functions in your organization work together to produce and deliver content. In this example, you open the 2-ring assembly in SOLIDWORKS Connected, and then you save it to the 3DEXPERIENCE platform. When you save data to the 3DEXPERIENCE platform, it saves the data in the active collaborative space. The name of the active collaborative space is visible on the right-hand side of the menu bar. You can change the active collaborative space without logging out or closing the session. The green checkmark indicates that the conversion was successful. Next, open the Linear Structural Validation app. You can use linear structural validation to perform structural stress, buckling, frequency, and thermal simulations. To help you define and run a simulation, you can use the assistant. The assistant lists commonly used commands and indicates whether your simulation meets the minimum requirements to run. You can right-click an empty section of the 3D area and select Assistant to open the assistant. Next, apply materials to the rings. Next, apply restraints. First, you apply a fixed displacement boundary condition to the large ring to restrain its movement in all directions. Then, you apply a fixed displacement boundary condition to the small ring to allow movement only in the direction of the applied pressure. Next, apply a general contact definition. The general contact method defines the behavior for contacting surfaces throughout an assembly. The benefit of the general contact method is that it detects any contact interactions between surfaces automatically. By applying a general contact definition, the app detects the contact interaction between the ring components as you pull one ring away from the other. Next, apply pressure. The pressure distributes a uniform load normal to the selected surface. A negative value reverses the direction of the pressure. Next, apply a global mesh. If required, you can change both the size and type of the elements within the mesh. Typically, a smaller element size yields more accurate results but increases the runtime. In this example, you use the default element type, which is tetrahedral, second-order elements, and you opt to use a small element size relative to the model to yield more accurate results. You can use the toggle mesh command to show or hide the mesh. Next, run the simulation. You can use the simulation status window to monitor the progress of your simulation and diagnose errors. To reopen the simulation status window, click Simulation Status in the Standard section of the action bar. Next, analyze the results. You analyze the results of the structural simulation by reviewing the contour plots of the von Mises stress, the displacement, and the factor of safety. The maximum von Mises stress is higher than the material's yield strength. The displacement plot shows which regions of the model are experiencing the largest displacement, based on your applied pressure. Regions of the model with a factor of safety larger than 2 are shown in gray. The maximum von Mises stress is higher than the material's yield strength. If stresses above the yield strength are not acceptable for your application, you can increase the ring's diameters to increase the contact area and reduce the localized contact stresses, or you can use a softer material to allow for larger deformations of the rings under the applied load. Next, create a report. A report uses text and images to describe the various parameters and results of your simulation. You can customize the content that is included in a report as well as edit the report after you generate it. The results images in the report are based on the current view of the model. Select the information to include in the report, for example, loads, restraints, materials, and mesh properties. The app saves the report as a document attached to the simulation object. You can access the report under the result node of the tree when you open the simulation or under the result node in the Simulation Finder app. Next, bookmark and share the results. You can create a bookmark for the structural simulation object, and you share the bookmark with your team to facilitate communication between team members. Your team members can review the von Mises stress throughout the model to ensure that the maximum values are within the acceptable operational limits. Enter the descriptive title that you gave the simulation. By clicking OK, the app creates a bookmark of the physics simulation object. The designated team members can access the bookmark of the simulation object using the Bookmark Editor app, which lets them organize and manage their data. Congratulations, you have successfully completed this example.